This dashboard displays live metrics for an AI agent managing 45,000 memory pages and 19 background operations with 0% failure. But feeding massive document volumes into standard vector databases causes structural instability. As context windows overflow, the system loses track of precise details. The problem intensifies when developers route routine background operations through those reasoning models. The models hallucinate, API calls timeout, and token costs spiral. To solve this, Y Combinator CEO Gary Tan open-sourced the exact codebase powering his personal AI deployments, GBrain. Instead of relying on vector embeddings alone, GBrain extracts specific entities to build a self-wiring knowledge graph. It strictly segregates predictable background tasks from stochastic model execution, pushing them into a durable Postgres job queue. And it hard-codes agent capabilities into version-controlled markdown files, rather than leaving operational logic to the runtime environment. Scaling an autonomous agent requires rigid, deterministic system design. Expanding context windows does not fix the underlying memory decay. As an agent ingests meeting notes, emails, and web research over several months, conflicting data naturally accumulates. GBrain organizes this data by enforcing a strict markdown ontology across its repository, splitting every file into a compiled truth section and a timeline section. The bottom half acts as an append-only evidence trail, where raw inputs stack sequentially. The agent synthesizes this evidence, rewriting the top half to reflect its best understanding. This update automatically extracts entities and creates typed links, forming a node network with 0 LLM calls. When querying that data, vector search often misses exact references, like employee names, while standard keyword search misses conceptual synonyms. GBrain solves this by layering reciprocal rank fusion with multi-query expansion. It runs keyword and semantic searches simultaneously, then mathematically fuses the results to capture exact matches and semantic proximity. This chart measures precision at 5 results. On identical datasets, the hybrid retrieval mechanism beats pure vector search by 31.4 points. Separating raw timeline from compiled truth guarantees that the agent retrieves relationship-aware context instead of semantic noise. Retrieving accurate data covers memory. The agent also has to execute heavy, ongoing background tasks like polling APIs and parsing JSON. Modern frameworks typically push this work through stochastic reasoning models, forcing an LLM to manage repetitive data pipelines. Under heavy load, the subagents fail to instantiate. This triggers spawn storms and gateway timeouts, crashing the background processes. GBrain eliminates this failure mode with Minions, a durable Postgres-native job queue embedded directly into the background architecture. This flowchart outlines the routing rule. If a task requires judgment, like triaging an inbox, it moves to an LLM subagent. If the input follows predictable steps, like pulling social media posts, it routes directly to the Minions queue. For the exact same workload, Minions drops wall time from a 10-second gateway timeout to under a second, costs 0 tokens, and hits a 100% success rate. The Postgres native queue survives gateway crashes, maintains a low memory footprint, and resumes jobs without losing state. Perfect execution reliability requires decoupling deterministic tasks from unpredictable reasoning models. The final pillar dictates how developers build and maintain the agent's capabilities. When capabilities are hidden inside opaque agent runtimes, the logic drifts. The agent generates logic that developers' numbers need, and within a few months, the underlying code silently breaks. This file structure illustrates the philosophy of thin harness, fat skills. All intelligence moolist into a version-controlled markdown document, exposing triggers, scripts, and audits in plain text. When the agent encounters a new bug, the developer corrects the behavior directly through the chat interface. By invoking the skillify loop, this fix instantly converts into a permanent routing rule inside the skill file. The system simultaneously generates deterministic tests for the new rule, enforcing the exact filing audit needed to ensure the behavior never drifts. GBrain ships with 34 of these standardized skills out of the box, governing everything from data ingestion to morning briefings. By treating capabilities as strict code files, failure modes become structurally impossible to repeat. Each new skill builds on the last, increasing the system's total utility with every iteration. Let's view the complete architecture. Inputs route into the Minions queue, updating compiled truth files, which wire the knowledge graph, queried through hybrid reciprocal rank fusion. Because the logic is deterministic, the system runs a dream cycle overnight, autonomously restructuring and consolidating memory. Simply expanding parameter counts and trying to force-feed larger context windows does not address the underlying structural instability of scaling an autonomous agent. Sustained performance relies on structured memory, decoupled task execution, and auditable, code-managed capabilities. AI agents achieve production-grade reliability only when predictable workloads move out of stochastic models and into durable, deterministic software architectures.